Hello students. So in the previous class we have discussed about the middle term splitting method and factorization of quadratic polynomial using this technique. And today in this class we will discuss about a new technique. And by using that technique we will factorize the same quadratic polynomial. And what is the technique? The technique is known as algebraic identities. Okay. So today we will discuss about what is algebraic identities and how this technique is used to factorize a quadratic polynomial of any type. Okay, so let's get started. Since we are going to study algebraic identities and we are acquainted with this term in class 8, we have studied what is the definition and meaning of an algebraic identities. So let's remind this. There we have studied three major terms. What are the terms? One is algebraic expressions. This is the first term. The second term is algebraic equation. Okay. And the third one is algebraic identities. Okay. So this is the first, second and third. From this three most important terms, the first one is algebraic expression. What is an algebraic expression? An algebraic expression is a term or a pattern which are formed by the variables. Okay. So algebraic expression are the patterns which are formed by the variables. For example, we can take, suppose we are going to make a m, single m. We need to create a m. In order to create one m, we need how many sticks? 1, 2, 3, 4. We need 4 sticks. Yes. Okay. Number of sticks. And in order to prepare 2m, we need how many sticks? 1, 2, 3, 4, 5, 6, 7, 8. We need 8 sticks. In order to prepare 3m, then we need how many sticks? 9, 10, 11, 12, 12 sticks. Similarly, you can see in order to prepare 1m we need 4 sticks, 2m we need 8 sticks, for 3m we need 12 sticks. It always follow a pattern. Okay, how? Because if you will multiply 1 with 4, it will be 4, 2 with 4, it will be 8, 3 with 4, it will be 12. So it follows a pattern. And if in this case we are going to find x number of m. Okay, x number of m means x may be anything. If you may find or create 10 m's or 20 m's or 50 m's. Then how many sticks are needed for that? It needs into 4 the 4x number of sticks. And this follows a pattern. That pattern is known as algebraic expressions. Okay? This is known as algebraic expressions. You can take one more example. If this is a rectangle, okay, this is a rectangle. If one of its side or length is x, you can say 2x, and its breadth is x. Okay, then you can see if this is 2x, then this is also 2x, and this is also x. If the question asks us to find the area of the rectangle, and we know the area of the rectangle will be length into breadth, that is 2x into x. Okay, 2x into x, that is 2 into x square. Now you will find another term, that is 2x square. This is an algebraic expression. So what we got? We got any algebraic expression must have a variable and an exponent. You can see an exponent. Okay, and it follows a certain pattern. Clear? So this is the definition of an algebraic expression. Now coming to the second point, that is algebraic equation. It is also a very simple term. It means, algebraic equation means it is an equality. Equality means equal to symbol between any two sides or between any two algebraic expression. Okay. For example, x plus 3, it is an algebraic expression, and 2, it is also an algebraic expression. Okay, so it is an equality between two sides or between two algebraic expressions. Okay, which is true for a certain value of variable. Okay, here we can get the value of x Yes or no? Or you can say for which value of x the LHS and the RHS will be equal. Okay. Suppose I am taking here the LHS is x plus 3 and RHS is 2. Now we need to find the value of x for which the left hand side is equal to right hand side. Okay. And if we do so, then we can say yes, it is an equation because both the sides are equal. So we need to find the value of x. By trial and error method, we can think the value of x like, suppose I can take x to be minus 5. Okay. If x is minus 5, then LHS is how much? Here we can find the value of LHS. X is minus 5. So minus 5 plus 3 is equal to minus 2. No, it is not true because LHS and RHS are not equal. So it is cancelled. Okay. Suppose I am taking x to be minus 1. Then what is the value of LHS? Minus 1 plus 3, that is 2. And RHS also 2. Now you can see that LHS and RHS are equal. Okay, that means both sides are equal for a given value of x, for a certain value of x. What is that value? That value is x is equal to minus 1. So only for x is equal to minus 1, LHS and RHS are equal. But if we will put x is equal to 5, are the LHS and RHS equal? Let's see. Suppose in this case, you will put x to be 5. Okay. Then what is the value of LHS? It will be 5 plus 3, that is 8. But here you have RHS 2. Does LHS and RHS equal? No, they are not equal. But they are equal. The condition is if x is equal to minus 1. Okay. So for only x is equal to minus 1 or for only single value of x, both LHS and RHS are equal, and that is an equation. So what is the definition of an equation? The definition of an equation is it is an equality between the two algebraic expression or two sides. Okay, for a certain value of the variable. Here the variable is x, so you can say that for the certain value of x. If the variable is different, then you can say that for certain value of that variable. Okay, so it is an algebraic expressions. You can take one more example to elaborate algebraic equation like x plus 2 is equal to 3. So what you need here in the place of x so that it will be equal to RHS. Here RHS has 3. So if we will put x to be 1, then yes, the LHS term is 1 plus 2 is 3. Then you can say LHS and RHS are same or equal, and hence it is an algebraic equation. But if we will put x to be any number, does the both side will same? No, they will not same. It is not an equality. So it is not an algebraic equation. Okay, so it is algebraic equation. So it is now clear. So coming to algebraic identities. What is algebraic identities? It is most important thing. So algebraic identities is nothing but an algebraic equation. We have already studied what is an algebraic equation. Okay, in algebraic equation we have only one value of x. But here, what is an algebraic identity? Algebraic identity is an algebraic equation. Okay, which is true for any value of the variable. I am writing this fast. Algebraic identities. It is an algebraic, note it down, equation, okay, which is true for any value of the variable. That means in algebraic equation case we find only one value of the variable, but here the value of the variable may vary. Okay, how? Let us define it. Suppose I am taking an example. If there is an algebraic expression a plus b is equal to b plus a, it is an equation or not? Yes, it is an equation because there is an equality symbol. Clear? Now we have to define whether it is an algebraic identity or not. Okay, so let's define how. Here we have two variables in LHS and RHS. LHS is A plus B and RHS is B plus A. Okay, suppose we have A is equal to 1, B is equal to 2. So what is the value of LHS? Then LHS will be how much? 1 plus 2, that is 3. And RHS will be how much? B is 2 plus 1 is equal to 3. That means for A is equal to 1 and B is equal to 2, both LHS and RHS are equal. Okay. Suppose we put the different value of A. Suppose we put A to be 7 and B to be minus 3. Does this two sides will same? Let us find. Okay, A is 7 plus B is minus 3. So 7 minus 3 is 4. And RHS minus 3 plus 7, that is 4. And here you can see both LHS and RHS are equal. For A is equal to 7, B is equal to minus 3. Let us put one more different value of A and B. A to be 1 by 2, B to be 2 by 3. So the value of LHS will be 1 by 2 plus 2 by 3. 3 to the 6, 6 to 3, 3 plus 4, that is 7 by 6. The value of LHS is 7 by 6 and the value of RHS is 2 by 3 plus 1 by 2. 3 to the LCM 6, 6 3 to 4 plus 3. And here you get the value of RHS is also same with the value of LHS. That means if we put any value of the variable, any value, you can take A to be 1 by 2 or B to be 2 by 3 or A to be any value and B to be any value. Then both the sides LHS and RHS are equal and it is known as algebraic identities. So this is the basic difference between algebraic identities and algebraic equation. In algebraic equation, both the sides are equal but only for one value of the variable. But here in algebraic identities, both the sides are equal for any value of the variable. Clear now? So, now let us discuss about what are the various identities or identical formula that may be useful in order to factorize a quadratic polynomial. Okay? So, what are the identical formula? The first identity is, one is, as we have known already about it, that is x plus y square. That means a plus b square. A plus b square is x square. Here a is x and b is y. And we know what is the value of a plus b whole square. It will be x square plus 2 into x into y plus y square. Okay. So this is the first identity of algebraic identical formula. Okay. Then coming to the second one. The second identity is identity 2. It is x minus y whole square or a minus b whole square. That is a square or x square minus 2xy plus y square. Okay. This is the second identity. And identity 3 is x plus y whole into x minus y is equal to, here x means a and y means b. Okay. So a plus b into a minus b is a square minus b square. In the place of a you can substitute x. So x square minus y square. Okay. You are already acquainted with this formula. Then the next identity is 4. That is x plus a whole into x plus b is how much? It is x square plus x whole into a plus b plus ab. Okay. So these are the 4 basic identical formula which are used to find the or to factorize the quadratic polynomial. Okay. because in all the cases you can see the highest power is or highest degree is 2. So these are useful for quadratic polynomial. So let us find the product of two linear polynomials, okay, using this 4 basic identities. So here are the two linear polynomials present, okay, all the terms are linear and we need to find the product of these two linear polynomial using this basic identical formula, okay. So let's start with the question number 1. In question number 1 we have to find the product using appropriate identities. We have to find this product and use any one of the identities among the 4. So here you can see there are two terms. The first term is x plus 3 and the second term is x plus 3. That means the two terms are equal. And whenever the two equal terms are being multiplied, okay, suppose this is multiplied with the same term, then the answer is square of the original term. Okay, for example, suppose this term is known as x and this is also known as x and they are being multiplied, then the result is x square. So you can write x plus 3 into x plus 3 jar x plus 3 whole square. Okay, now you can see this term is resembles with the identity 1. In identity 1 we have x plus y whole square is equal to x square plus 2xy plus y square. Now the LHS is equal to this LHS. Resembles means they are similar, not equal, they are similar. So here you can see x, in the place of x we have also x, so we can write x is equal to x, and in the place of y here we have 3. Clear? Now you can use this formula. So the formula is x square, that means x square plus 2 into x into y, here y is 3, plus y square, here y is 3 square, that is x square plus 2 3 just 6x plus 3 square just 9. So finally we find that x plus 3 square is x square plus 6x plus 9 by using the identity 1. Okay, are you getting this? So coming to the next question. In the next question we have also two linear terms, two linear polynomial, and these two linear polynomial 3x minus 7, here also 3x minus 7. It means the two linear equation or polynomial are equal. So we can write 3x minus 7 into 3x minus 7 jar 3x minus 7 whole square. Now you can see this formula or this term is resembles with the identity 2. Yes or no? Here x minus y square, here this something minus something square. So this is resembles to, I am writing this x minus y square. So here what we have? Here x is equal to how much? 3x, and in the place of y we have 7. Okay, it is now clear. So as the formula of x minus y square is x square, I am writing this x square minus 2xy plus y square. So in the place of x you have to put 3x because x is equal to 3x. So 3x square minus 2 into x, in the place of x again put 3x, into in the place of y put 7. Clear now? Coming to next one, y square means 7 square. So whenever you are going to find the square of 3x, it means you have to find the square of 3 as well as the square of x, not only 3 square x. No, this is wrong. You have to find the square of 3 as well as x. So it will be 3 square is 9, x square is x square, minus 2, 3, 7 are the constant term. So 2 3 is 6, 6 7 is 42, and here x plus 7 square is 49, and here is the answer. So now this quadratic polynomial is again product to get 9x square minus 42x plus 49. Clear? So these two equations are resembles with identity 1 and identity 2. Now coming to the question number 3, where we have the two linear polynomial x plus 7 and x minus 7. That means the two linear polynomial or the two terms are not equal. This is not equal to that polynomial. Okay? So now we have to find this formula resembles with which identity. Okay? So let's find. Here what we have? X plus 7, x minus 7. Here x, here x. That means in the two terms the first terms are equal and the second terms are also equal. Only difference is that if it is plus then it is minus. So it is quite similar with this identical formula. What is that? That is, I am writing this x plus y into x minus y. Okay. Now you see this and this are completely similar, not equal but completely similar. Here x, here x, here x, here x. And in the place of y and y, here 7 and 7. So you can write x is equal to x and y is equal to how much? 7. And you know the formula of x plus y into x minus y is x square minus y square. So you can put in the place of x, same x square, and in the place of y, you can put 7 square. So it gives x square minus 7 square, 49. You can use by using which identity? Identity 3. Okay. So now the product of x plus 7 into x minus 7 is x square minus 49. Okay. Finally, you can write this. Now it is also clear. Let us discuss about another question of this identity. Suppose we have the question y square minus or plus 3 by 2 whole into y square minus 3 by 2. Okay. Now we have to find whether this formula resembles with any one formula with this identities. You can see in the first term and in the second term, in these two terms, the first place are equal. Here y square, here y square. And the second place are also equal. Here also x, first place equal, second place are also equal. Only difference is plus here, minus here. Here also plus, here also minus. That means this product is resembles with x plus y into x minus y. So here what we have, you can write here x is equal to how much? See here x is y square. In the place of x here y square is written. So you can write x is equal to y square and see y is how much? Y is 3 by 2. Okay. Now we get the value of x and value of y. Now we have to put the formula of x plus y into x minus y. And you know the formula of x plus y into x minus y is x square minus y square. So in the place of x, just put y square. Then again square is present because in the place of x we have to put only y square. Then of square minus in the place of y you have to put 3 by 2 whole square. Okay. Square, whenever two exponents are present, exponent of exponent, then the two exponent will be multiplied. So 2 into 2 is 4 minus here 3 square is 9, 2 square is 4. This is your answer. And hence you can write y square plus 3 by 2 into y square minus 3 by 2 is equal to y fourth minus 9 by 4. Okay. So let us talk about some different type of question. Okay, where we have the two linear polynomial to be different. Okay, they are completely unequal. So let's have the question. Here we have two terms, x plus 3 and x plus 5. You can see in these two linear polynomial, the first place will be same, but here the second place are not equal. Here 3 and here 5. Now we have to find this two quadratic polynomial of this product is resembles to which identity? You can see in the fourth identity we have here x and here x. That means the first two places are equal. But here the two other places, here a and here b, are unequal, and in between them plus is present. Here also plus is present, and these two terms are unequal. That means this is resembles to the identity 4. So we can write x plus 3 and x plus 5 is resembles to x plus a into x plus b. Okay. So here a is how much? 3 and b is 5. Clear? Now we have to put the formula of this identity 4. The identity 4 tells us that x plus a into x plus b is x square plus x whole into a plus b plus ab. So x square means here x present, so x square plus x is the variable. In the place of a you have to put 3, and in the place of b I put 5, and ab means 3 into 5. So it will be x square plus 3 plus 5 ja 8. 8 into x ja 8x plus 3 into 5 ja 15. So this is your answer. Hence the product of x plus 3 into x plus 5 is equal to x square plus 8x plus 15, and it is a quadratic polynomial. Okay. Hence you find the product of these two linear polynomial. Now in the question number 2. In the question number 2, here also the first two terms or the first two places contain x, but the second two places doesn't contain the same number. They are different number. Here also they are different number, but here it is plus, but here it is plus, but it is minus. So we have to first make it plus, so that this total product is resembles with the identity 4. How we can convert this minus into plus? See how I am converting it. So it is written as x plus 4. There is no need to change anything. But here we have to write x. We need in between x plus and b there is a plus sign. So we have to write plus here. So I can write it minus 5. Yes or no? Yes, because plus minus are minus. So I can write x minus 5 as x plus of minus 5. Okay. So now this product is resembles with the product x plus a into x plus b. Okay, where a is 4, x is x, no doubt. Here x present, no doubt, no change. And b is minus 5. Always keep in mind it is minus 5. Now the formula of x plus a into x plus b is x square plus x whole into a plus b plus ab. So x, so x square plus x, in the place of a put 4, in the place of b put minus 5 plus, this should be bracket. So a is 4 into b is minus 5. So x square plus x, 4 plus minus 5, 4 into 5 ja minus 20. Hence the final answer is x square. 4 minus 5 is minus 1. And minus 1 into x is minus x. So I am writing directly minus x. Plus minus 20. And this is our answer. Okay. Now see the question number 3. In question number 3 we have in this both terms the first two places contain the same term. Here 3x, here 3x. But the second places contain the different terms. Okay. So this is resembles with the identity 4, but we have to make this sign to be plus first in order to make them similar. So we have to write it like as 3x, we have to make it positive. So 3x plus minus 2, because it will be plus minus minus 3x minus 2 into 3x plus, this is minus 6. Okay. So now you can say now this product is resembles with this formula x plus a into x plus b, and here you can see x is how much? 3x, but here x is x, but here x is equal to 3x, a is equal to minus 2, and b is equal to minus 6. Now put the formula of x plus a into x plus b, that is x square plus x whole into a plus b plus ab. So it is equal to x square. In the place of x, we have to put 3x. So it will be 3x whole square. Plus, in the place of x, you have to put 3x whole into minus 2 plus minus 6 plus a into b, minus 2 into minus 6. Now 3x whole square, not only 3x square, 3x whole square, that means 3 square, 9x square plus 3x minus 2 minus 6 is minus 8 plus 2 6 are 12 minus plus. So the final answer is x square, 9x square. Now you can see it will be 3 into 8 is 24x minus plus 12. And hence you get 9x square plus minus 24x plus 12. And here we get the final answer of this product of the two linear polynomial, that is 9x square minus 24x plus 12. Okay.